Okay, dear students, another question. A pre-tensioned rectangular concrete beam of 50 mm wide and 300 mm depth is prestressed with three straight tendons, each having a cross-sectional area of 50 mm square to an initial stress of 1200 Newton per mm square. The tendons are located at 100 mm from the soffit of the beam. If the modular ratio is 6, the loss of pre-stressing force in kilonewton due to elastic deformation of concrete only is dash. So it has been asked in 2017 for 2 marks. So let's understand this question by drawing the figure. What they have asked is pre-tensioned rectangular concrete beam, and they have given the dimensions. Okay, so dimensions, width is 150 mm and depth is 300 mm. So you can see I am drawing over here. This is okay. So this B is 150 mm and the depth is 300. Okay, now mm means the half will be 150. Okay, now another thing, they have told us that we are using three straight tendons and each having cross sectional area of 50 mm square. Okay, and the initial stress they have given 1200 Newton per mm square. Okay, so let's write the data. So here initial stress is equal to 1200 Newton per mm square. Okay, and cross section of tendon is 50 mm square. So there are three number of tendons. So we know that suppose I am drawing the cross section. This is your cross section and this is your longitudinal section like this. So this is beam. These are some reactions over here. Okay, so this is your actual, this is your depth D, which is 300 mm. Okay, so this is your middle portion. Now see, they have written tendons are located at 100 mm from soffit. So what do you mean by soffit? Soffit is this portion, bottom one, from bottom, this bottom portion is known as soffit. Okay, so 100 mm from soffit. So this is 150 and this is 150. Okay, and 100 mm from soffit means somewhere over here. Okay, this is your 100 mm from bottom. Let me draw over here. So this is somewhere over here. Okay, I hope you are able to understand this. This is 100 mm because total half is 150. So this I am denoting, this distance I am denoting by E, small e. So it will be 50 mm. Okay, it is very simple to understand. So E is 50 mm. Now see, I am writing over here. We know that stress, what is stress? Basically stress is force upon area. Now we need to find out the force. So force will be stress into area. So area we know, we are cross section of one tendon is 50 mm square. So basically there are three tendons. So area will be 3 into 50 this will be in mm square multiply by what is stress? Stress is 1200 Newton per mm square. So the stress is stress is 1200 Newton per mm square. Okay, so let's find out the force. Let me write over here. This is force P is equal to 3 into 50. It will be 150 into 1200. So 150 into 1200. So answer is 180,000. So 180,000 Newton. So this is the force. Okay, and we know the value of E also. E we have seen from the figure, it is 50 mm. How we have got it? We know from the figure. Okay, now stress in concrete. Basically stress in concrete at the location of steel. Okay, so at the location of steel, here the formula is P by A plus PE by Z. Okay, so what is P? First of all, see here we need to find out the value of Z. Okay, so Z is I by Y, we all know, but in this case Y will be basically eccentricity, we go I by E. So and I is BD cube by 12. So what is B? Width is 150, depth is 300, so it is 150 into 300 cube by 12. Okay, so it will be around 150 into 300 cube divided by 12. So it is around 3375 mm raised to 4. This is the value. Okay, now I by E. So what is Z? Z will be I by E. So E is 50 mm, right? So let us divide this value by 50. So we will get 675. This is in mm cube. I hope you are understanding. Okay, so let us put in this equation P by A plus P by, so stress is equal to P. So here P we know it is 180,000 Newton. Now A is cross section area of this beam, that is 150 into 300. Okay, plus PE by Z. So PE again 180,000 into E is your 50 divided by Z is 675. Okay, so here the stress will be, let me find out, we'll calculate quickly. 180 150 divided by 300 plus okay, so answer is some, we are getting 5.33. okay, so 5.33 Newton per mm square. This answer we are getting. Okay, now loss of stress. Okay, so let us find loss of stress is equal to, the formula for loss of stress is M into FC. M is your modular ratio, and modular ratio they have given, that is 6. Okay, modular ratio is basically the ratio of the Young's modulus of steel upon Young's modulus of concrete. Okay, so ES upon EC, that is M, so 6 into 5.33. so how much loss of stress we are facing? Multiply by 6, so answer is 32. Okay, so 32 Newton per mm square, 32 Newton, 32 Newton per mm square. So this is your loss. Okay, so simple, for 1 mm square, 1 mm square area, we are facing a loss of 32 Newton. So how much tendon area we are having? We are having 3 tendons, and each tendon is having an area of 50 mm square. So basically we are having 150 mm square. So how much pre-stress loss will be there? For 1 mm square it is 32. So for 150 mm square it will be 150 into 32. 150 into 32, how much it is? 32 into 150, 4800. Okay, so answer is 4800 Newton. So basically it is 4.8 kilonewton, because we have asked in kilonewton. Okay, so here you can see the answer which they have asked in kilonewton, right? So it will be 4.8 kilonewton. Okay, thank you very much.